The Vehicle Stability Assist System, or VSA, is a critical safety feature that helps maintain control of your vehicle, especially during challenging driving conditions like wet roads or sudden maneuvers. When the VSA light illuminates on your dashboard, it's communicating important information about the system's status. Understanding what different light patterns mean is crucial for proper diagnosis. A flashing VSA light indicates the system is actively working to maintain vehicle stability. This means VSA has detected a loss of traction and is intervening by applying brakes to individual wheels or reducing engine power. If you see the VSA light accompanied by an exclamation point, this indicates a more serious issue. It could signal low brake fluid, a brake system malfunction, or a complete VSA system failure requiring immediate attention. There are four primary causes responsible for most VSA light activations. Steering angle sensor drift accounts for about 35% of VSA issues, often occurring after wheel alignments or steering system work. Wheel speed sensor contamination represents 28% of VSA problems. These sensors, located at each wheel, can become dirty or damaged, sending incorrect speed data to the VSA system. The remaining causes include yaw rate sensor calibration loss at 22% and brake fluid contamination at 15%. Each of these components plays a vital role in the VSA system's ability to detect and correct vehicle instability. Modern Honda and Acura vehicles from 2024 onward feature advanced diagnostic capabilities. These include OBD3 compatibility, wireless diagnostics, and AI-enhanced error detection that can predict component failures before they occur. To properly diagnose VSA issues, start with basic checks including battery voltage, brake fluid level, and tire pressure. These simple steps can identify many common problems before using advanced diagnostic tools. For accurate code reading, use manufacturer-specific scan tools rather than generic OBD readers. Generic tools miss about 40% of VSA-specific diagnostic codes, making proper diagnosis difficult. Finally, perform a road test to verify system operation. Many VSA issues only appear during dynamic driving conditions and cannot be detected through static testing alone. This comprehensive approach ensures accurate diagnosis and proper repair. The VSA reset procedure varies depending on your vehicle model and year. For most Honda and Acura vehicles from 2018 to 2024, you can perform a basic reset yourself. First, ensure your engine is off and the parking brake is engaged for safety. Turn the ignition to the on position, but do not start the engine. Press and hold the VSA off button for exactly 10 seconds. Then start the engine and drive above 12 miles per hour for 30 seconds to complete the reset. Newer vehicles from 2024 and beyond require more sophisticated diagnostic equipment for complete VSA system resets. This typically requires dealer-level tools like the Honda Diagnostic System. The advanced reset involves connecting Honda HDS or equivalent diagnostic equipment to perform steering angle sensor calibration and yaw rate sensor zero-point calibration. The system also verifies wheel speed sensor signals and completes a full initialization sequence, followed by a road test to ensure everything is working properly. Understanding the key components helps with proper maintenance. The VSA system relies on multiple sensors, including wheel speed sensors, steering angle sensors, and yaw rate sensors. Regular maintenance is crucial for VSA system reliability. Brake fluid should be replaced every 3 years, as contaminated fluid can cause system malfunctions. Wheel speed sensors require regular cleaning to function properly. Dirt and debris on the sensor ring can cause false readings and trigger the VSA light. Clean sensor rings during brake service and ensure proper wheel alignment to reduce sensor wear. These simple maintenance steps can prevent 60% of VSA-related issues. After any VSA repair, performing a complete system reset is crucial. This prevents recurring issues and ensures all components are properly synchronized. Remember, a $20 reset procedure can prevent a $2,000 comeback repair.